Okay, next up we have something referred to as a Vigenre table, and this is a multi-alphabet substitution cipher. All right, so basically a polyalphabetic substitution cipher. So it consists of your message and a keyword that only you and the other person will know. All right, so you need to share that keyword, but as you can see on the table on the right-hand side here, your keyword will go on the left, your message will go on the top, and to make things more difficult to guess, you should take the spaces out of your message. All right, so I'll show you how this works in just a moment, but we're going to basically have our message, and then we're going to have our keyword, and that keyword will repeat over and over again until it fills up the length of our message. All right, so as an example, let's say we have this specific phrase. I want to pass this on to my friend. Okay, say I'm Bob. I want to talk to Alice, my dear old friend. We've been best buds since the dawn of the computer age, right? So I want to send to Alice this message that says Pluralsight Security Plus rocks. All right, so that's the message. And then my keyword is going to be CompTIA, okay, C-O-M-P-T-I-A. What I'll do is repeat that keyword over and over and over again until it basically takes up the same number of characters as my message. And then I will, in turn, then encrypt that message based upon that Vigenre table, okay, which I'll explain in just a moment. But as you can see, the message, the keyword, which again repeats, and then the encrypted message below. So if the person doesn't have the keyword that I used, they're not going to be able to very easily decipher that. Now with a computer in real life, you could brute force this. Now there'd be quite a number of variations to try. A computer could obviously do it, but depending upon the length of your keyword, it could be extremely lengthy. So if we look at an example, okay, here's our message and our keyword. So here's a Vigenre table. All right, so our message it goes up on top. Our keyword is on the left, and basically we have Pluralsight Security Plus rocks as the message, as again, CompTIA over and over again as the keyword, and our resulting encrypted message. So our keyword, you'll see here, on the left, we have C is the very first letter of our keyword, right? CompTIA. So we go from C all the way over until we get to P, which is the first letter of our message. Okay, so where those two intersect is the letter R. So that is where you see here, P over C, and the resultant R is the encrypted letter. The next one, all right, is going to be the same thing, L and O. So O from CompTIA, that's the keyword on the left. On top, we have L as part of our message. Okay, that's the L in Pluralsight Security Plus rocks. We find out where those two intersect, which is Z, and as you see, now that's the second letter of our encrypted message. And you would proceed through that as it goes through the entire message, and then that would give you your message. Now, if the other person doesn't know that keyword, it's going to be very difficult for them to decipher that. However, as I said, with a computer, they could brute force that because in reality, it's 26 to the n minus 1, right? The n being the length of the keyword. So that's how many variations there would have to be in a brute force attack before you would exhaust all possibilities. But again, with a very powerful computer, that is very doable. Okay, so a Vigenre cipher is really not considered a secure algorithm or a secure way of communicating outside of just maybe friends passing messages. But if you want to do anything that has a high degree of security, obviously, this would not be the method that I would choose.